All right, here we go. Algebra 2. Lesson 2-7. We're almost halfway through the assignment. So we've got a parabola here, and we have a line, and we're supposed to find the solution. So, you know, I think I've shown before, the way they want us to do this, I think, is set the two equations equal to each other. Have the negative x plus 3 equal the x squared plus 5x plus 8, and see what we get for an answer. If it's imaginary, it means there's no solution. So let's just give it a whirl here and see what happens. If you add that x over here, that'd be a 6x. If you subtract that 3 over there, that'd be a 5. And I think this looks to me like this little old problem will even factor now. The easiest way to do it, the x plus 5 and x plus 1. There's your 5x and 1x makes your 6x in the middle, and the 5 times the 1 makes the 5. So when you set each of those equal to 0 and solve, because you have the zero product property, you've got two things here, basically, that, you know, you multiply this one times this one. And if you think about those as being like two different letters, like an A times a B, and they equal 0. Only way for that to happen is if one of these two things is a 0. I mean, think about it. Is there anybody come up with an example where A and B multiply and equal 0, but A or B isn't 0? It's not possible. So that's what we're doing here, is figuring out when the x plus 5 is 0, when the x plus 1 is 0, which subtract the 5 on both sides, subtract the 1 on both sides. And then it wants the order pairs, because our original problem up here had x and y in the problem. So we need both. These are just the x values. So then to find the y value that goes with each one of them, put an x in here. I'm going to use the second equation here. The y equals negative x plus 3. So if I put into that problem, for x, a negative 5, this would be a negative 5, so that'd be a positive 5 plus 3. So that's 8. And if I put a negative 1 in there for x, that'd be a negative 1, which is 1 plus 3, which is 4. So algebraically, if I'm really feeling lazy and I'm not, and I know how to do it this way, you need to know how to do it both, but sometimes I might run over to Desmos, put both equations in, and actually just have Desmos find the answer for me. It's easier. It's a lot lazier. And sometimes it's more certain I get the right answer because I just have to make sure I type correctly. So let's see what happens though when I put these in. And algebraically, that's how you can work that problem. So good luck out there. You got this.